For decades, we called the Mariana Trench a dead abyss, silent, empty, untouched. Then scientists found sealed blue mud rising from 20 kilometers beneath the Earth, burning as caustic as bleach, but bursting with signs of life. If organisms survive here, what does that mean for how life begins and where it might exist beyond our planet? The myth collapses now. Our descent into the unknown starts here. Textbooks once described the deep ocean as a barren wasteland, a place where pressure crushes metal and life cannot take hold. For most of the 20th century, the Mariana Trench was a blank space on the map. Its depths measured, but its secrets left untouched. In 1960, two men, Don Walsh and Jacques Piccard, descended in the bathyscaphe Trieste to Challenger Deep, nearly 11,000 meters down. Their brief glimpse revealed only pale sediment, a single flatfish, and silence. For decades, that image stuck, an empty pit, lifeless and unchanging. The numbers tell the story of our ignorance. More people have walked on the moon than have visited the bottom of the Mariana Trench. As of today, only 27 humans have made the descent. Most of what we know comes not from explorers, but from machines, remote landers, robotic submersibles, and echo sounders, tracing the contours of the trench in darkness. Even now, less than 0.001% of the deep seafloor has been explored at high resolution. It's like trying to understand the Grand Canyon by lowering a camera on a string in the middle of the night, then guessing at the rest. The myth of the empty abyss was built on absence. Absence of light, absence of warmth, absence of evidence. Early expeditions returned with little more than mud and mystery. Scientists assumed that pressure, over 1,000 times greater than at sea level, would destroy any complex life. The cold, hovering just above freezing, seemed just as unforgiving. Generations of students learned that the deep sea was the end of the world, a graveyard for sinking debris and the occasional lost whale. But the ocean does not give up its secrets easily. Every new instrument, every improved submersible, every core sample pulled from the darkness has chipped away at that old certainty. The deeper the search, the more the data refused to fit the myth. Reports began to surface of strange chemical signatures, fleeting shapes in the lights of underwater vehicles, hints of movement in places that should have been still. The deeper the descent, the more the story started to unravel. What have we missed, hidden beneath kilometers of crushing water? If our maps are mostly blank, how much of what we believe is simply the shadow of our own ignorance? The evidence waits, sealed in the rocks and mud, for those willing to go deeper. A drill bit, encased in steel, bites through the upper crust of the Mariana Forearc. It pushes deeper, chasing a plume of ancient mud. The target is a mud volcano, an underwater mountain half the size of a city, built from material forced up from nearly 20 kilometers beneath the seafloor. When the core finally reaches the surface, the team braces for what's inside. The mud is not brown or gray, but shockingly blue. It reeks of chemicals. The pH 12, strong enough to burn skin, as caustic as household bleach. The gloves and sample bags are mandatory, but even so, caution isn't always enough. Sometimes, as pressure drops, the bags swell and burst, releasing a hiss of methane. In some cases, the gas escapes at rates up to 0.8 liters per second. The mud is so alkaline, it can strip paint, yet sealed within this hostile sludge are chemical fingerprints of life. The samples, preserved for millions of years, are a time capsule from Earth's interior. Scientists extract pore water and analyze the chemistry. They find hydrogen and methane, products of a reaction called serpentinization, where water meets mantle rock under crushing pressure. This process not only fuels the mud volcanoes, but also creates a chemical playground for microbes. Under an electron microscope, the blue mud reveals traces of extremophiles, Microorganisms adapted to survive in conditions that would destroy almost any known life. Their cell membranes are engineered to resist the corrosive, bleach-like environment. Some use proton pumps and unique biochemistry to keep the deadly hydroxide ions at bay. These are not passive survivors. They are thriving, multiplying, building entire communities in a place that should be sterile. The mud's origin story stretches back to the mantle wedge, where slab-derived fluids percolate through fractured peridotite. The result is an alkaline, methane-rich slurry that rises through the fault lines and erupts as mud volcanoes. The chemical conditions here are so extreme, they closely resemble what scientists expect to find on Enceladus, a moon of Saturn. Both worlds feature alkaline fluids, hydrogen and methane, as energy sources, and the absence of sunlight. The resemblance is more than coincidence. If life can survive in the Mariana's caustic blue mud, then the same chemistry could support life in the subsurface oceans of other worlds. Every step of the process is a test of what life can endure. The team's instruments detect not just the presence of microbes, but active metabolic signatures. Some of the organic molecules they find could only have been made by living cells. The mud, sealed away since before humans walked the Earth, is alive. This is not the dead end of evolution. It is a laboratory, powered by chemical energy, where the rules of biology are rewritten under impossible pressure. How many other worlds could look like this beneath their frozen shells? And if life began in places like these 4 billion years ago, what else waits beneath the surface, sealed away, surviving in the dark? The mystery remains. In 2018, a seismic experiment in the Central Mariana Trench uncovered a planetary secret hiding beneath the waves. Ocean bottom seismographs tracked tremors rippling through the crust and upper mantle, revealing something no one had expected. The subducting Pacific plate was saturated with water, far deeper and in far greater quantities than models predicted. Hydrated minerals, formed by water seeping into cracks as the plate bends, carried this water down nearly 30 kilometers below the seafloor. The numbers were staggering. The trench was dragging at least 4 times more water into Earth's interior than scientists had ever measured before. This is not a trickle. It is a hidden flood, a conveyor belt moving seawater from the surface into the planet's mantle. The water does not simply fill cracks and disappear. Instead, it becomes chemically locked within minerals like serpentine, traveling with the sinking slab deep into the Earth. Globally, subduction zones like the Mariana may be swallowing 3 times more water than previously thought. The amount trapped could rival all the world's surface oceans combined. Dr. Maria Lopez, a geophysicist on the project, called it a planetary plumbing system. The trench acts as a massive siphon, drawing water into the rocks, where it is stored for millions of years or even longer. Yet, the numbers do not add up. More water enters the mantle, then comes back out through volcanic eruptions. The imbalance remains unexplained. Some of this water may be locked away forever, changing the chemistry of the deep Earth, fueling melting, and driving the creation of new minerals. As the Pacific plate sinks, it carries not just rock, but the memory of oceans, sealed beneath our feet, reshaping the world from below. The question lingers: what happens to all that water, and how does it shape the life and chemistry above? At nearly 11,000 meters down, the myth of untouched wilderness collapses. In 2019, a robotic lander retrieved amphipods from Challenger Deep, tiny crustaceans that have survived here for over a decade, growing far larger than their shallow water cousins. But inside their bodies, scientists found something impossible to ignore: radioactive carbon-14, a fingerprint left by nuclear bomb tests from the 1950s and the 1960s. Fallout from Cold War detonations had traveled across the world, entered the ocean, and found its way to the deepest trench on Earth, moving through the food web in just a few decades. While ocean currents take centuries to complete a single circuit, the story only gets darker. Tissue samples from these Hadal amphipods contain polychlorinated biphenyls, PCBs, at concentrations 50 times higher or higher than those found in crabs from one of China's most polluted rivers. Mercury, too, had settled in their cells. These chemicals, banned on land, persist for years in the cold, slow metabolism of deep sea giants. The very traits that allow life to survive, long lifespans, and slow growth, turn these creatures into living archives of human contamination. The evidence is not just inside the animals. On the seafloor itself, explorers have discovered plastic bags and candy wrappers, preserved for centuries in the lightless cold. Ingested by amphipods and other scavengers, these fragments break down into microplastics, entering the bodies of creatures that have never seen sunlight. Victor Vescovo, after his record-setting dive in 2019, described finding trash at the planet's deepest point as a gut punch, a sign that nowhere is truly beyond our reach. The abyss was once imagined as a fortress against human impact, but the data tells a different story. Pollution, fallout, and waste have seeped into every corner, riding the currents and food chains to places no one expected. If the deepest trench is vulnerable, what does that mean for the rest of the ocean? The question hangs in the darkness, unanswered. A submersible descends through pitch-black water, guided only by sonar and the faint glow of its own lights. At nearly 10,000 meters, it hovers above a scene no textbook ever predicted: a dense city of life thriving in the chemical dark. Tube worms, clams, and mollusks cluster in colonies so thick they carpet the seafloor, feeding not on sunlight, but on methane and hydrogen bubbling up from cracks in the earth. Bacterial mats, white as snow, spread across the mud, fueling an entire food web with energy drawn from the planet's interior. These are the deepest animal communities ever recorded, 9,743 meters beneath the surface, discovered by the Fendouge submersible in 2024. But the real shock comes from the invisible world. During the Mir expedition in 2025, researchers collected 1,648 sediment samples from the trench and ran them through a genetic sequencer. The results shattered every expectation. They cataloged 7,564 distinct microbial species. Nearly 9 out of 10, 89%, were completely unknown to science. The trench is not a graveyard. It is a genetic frontier, overflowing with life that has never been seen before. Dr. Liu Wei, a marine biologist, and Dr. Ana Gomez, a geneticist, shared the moment the data appeared on their screens. The patterns were unmistakable. Bacteria, archaea, even deep-sea fish and amphipods, organisms separated by billions of years of evolution, had all developed nearly identical antioxidants to survive the crushing pressure. In these depths, the environment itself shapes life, pushing it toward the same solutions again and again. Evolution is not a random walk here. It is a forced march, steered by chemistry and physics into forms that work. The scale of this discovery is almost impossible to grasp. Each new genome is a potential blueprint for survival in extremes, genes, enzymes, and biochemical tricks that could rewrite what we know about biology. If life can thrive in methane-powered cities at the bottom of the world, what else is possible in the universe? And with so much left unsampled, what stranger forms might still be waiting, sealed in the darkness below? For decades, biology textbooks insisted that a single chemical, TMAO, held the secret to surviving the planet's deep pressure. The theory was simple. The deeper a fish lived, the more TMAO it would produce to keep its proteins from collapsing under the crushing weight. But in 2025, a team of scientists studying 11 species of Hadal fish from the Mariana Trench published results that shattered this idea. Their data showed no significant increase in TMAO below 6,000 meters. The deepest fish, living in a world where pressure can crush a submarine like a soda can, had no more of this supposed molecular shield than their shallower cousins. For Dr. Liu Wei, a researcher on the project, the moment was unsettling. "We thought we understood the rules down here," he said, "but the ocean keeps rewriting them." The findings forced a reckoning. If TMAO isn't protecting life at the bottom of the world, something else must be. But what? The mystery remains sealed in the darkness, waiting for the next discovery to break it open. 8,900 meters below the surface, where the pressure is enough to crush steel, scientists isolated a predator so small it passes through the finest filters, yet its influence is everywhere. A single drop of Hadal sediment contains not just bacteria, but viruses hunting them. In 2022, researchers sequenced the genome of a bacteriophage pulled from these depths. This virus doesn't drift aimlessly. It infects and replicates inside the trench's native bacteria, hijacking their machinery in total darkness. The infection is active, not a fossil or a remnant, proof that even here, life is locked in constant struggle. Each viral attack shatters bacterial cells, releasing nutrients and DNA, fueling a microscopic arms race that shapes the entire food web. The presence of a functioning virus at nearly 9 kilometers down means no organism is ever truly alone or truly safe. The abyss is not just a sanctuary for survivors, it's a battlefield, invisible to the naked eye. If a virus can hunt at the edge of the Earth, what other unseen forces might be at work in the darkness? A map of the trench looks complete, but the reality is emptier than it appears. Less than 0.001% of the deep sea floor has been mapped in detail. Most of what lies beneath remains untouched, unseen, and unsampled. Even in the age of satellites and autonomous submarines, the high-resolution maps cover only a fraction of the abyss. Cores drilled from the seafloor represent a vanishingly small patch, far less than 0.01% of the trench's vast area. Cold seeps, those underwater vents that power entire ecosystems, are even rarer in our records. Only about 0.1% of their possible locations have been visited or measured. The rest is an expanse of darkness and pressure, stretching for hundreds of kilometers in every direction. Each new dive, each sample, is a pinprick in a continent-sized unknown. If 89% of the microbes found so far are new to science, what else could be waiting, just beyond the reach of our instruments? We have mapped less than 0.001% of the deep sea floor. Yet our trace pollutants and plastics are already there. The abyss is not untouched. It is a living frontier shaped by our reach and our ignorance. As technology in these depths, the next discovery could rewrite what life means. The real unknown is not the trench, it is how we choose to explore it. Share your thoughts below.